Welcome everyone, and my name is Chris Knight. I'm the director of the Open Aerial Imagery Association, and this is our Open Aerial Imagery Multi-Source Interpretation and Analysis Seminar Series. I will pass it over to Cristiano.
Thanks, Chris. Good morning, afternoon, evening, everyone. My name is Cristiano. I'm based in Italy, and I work for HOT, Humanitarian OpenStreetMap Team. Again, that's me. I'm a Senior Technical Advisor for HOT, Humanitarian OpenStreetMap Team. And the organization is based in the US, but we have offices in different parts of the world. Mostly, the main ones are in Indonesia, and Tanzania, and Uganda. And we're about to open three new ones, which I'll talk about it later. But just to provide a vision of what HOT's vision is, a world where everyone is counted, map data is accessible and used in decisions that save and improve lives, and everyone can engage and contribute to the map. And we mostly work on three areas: disaster response and disaster preparedness, sustainable development, so all the applications related to sustainable development, urban planning, health system, education, and so on, and technology. HOT is an international organization dedicated to humanitarian action and community development through open mapping. Open mapping is really our key activity. If anyone is familiar with OpenStreetMap, I believe many of you have heard of OpenStreetMap, but it's a project that started over 10 years ago in the UK. And then in 2010, when the big earthquake struck Haiti, it was the first time that the community that contributes and created OpenStreetMap actually used OpenStreetMap to support humanitarian response. So this was the map of Port-au-Prince just before the earthquake happened. There was already a good amount of data, but really the teams on the ground needed detailed, accurate representation of where the buildings were and also how to get there. And so the community came together. It was the first time that the satellite imagery was made available by the companies at the time, Spatial Imaging, GeoEye, and they made that satellite imagery available, and the map was created, and all the data was made accessible to the responders. Again, if you're not familiar with OpenStreetMap, if you go to osm.org or openstreetmap.org, you can get an idea of what it looks like. To say it in a simple definition, it's the Wikipedia of maps, where everyone can contribute to the map anywhere in the world. This is done in different ways, but the key difference from other sources of map data, like for example Google Maps or other data set, all of the data in OpenStreetMap is open and freely accessible. Anyone can download it and use it. And OSM works basically in two ways. One is through remote digitizing of imagery, satellite imagery, aerial imagery, drone imagery, and then through the local knowledge that adds the information to the map. So, for example, if we look at this image, and if you go to OpenStreetMap and you create an account, you can start tracing and the imagery that is available. So maybe in your own hometown or anywhere in the world, really. You can trace roads, buildings, and that information is stored and made available to anyone. Then, like for example, in this image, we can see that someone put the name to that church in the middle of the screen. So that's the information that gets added from the ground, from the local knowledge. So it's a combination of remote tracing, remote mapping, and knowledge information captured on the ground. And as I mentioned before, OSM is a collaborative project that creates open data. All the data that gets created and put into OSM, it's shared under an open license called ODBL, Open Database License. That means that anyone can really use the data, and not just look at it, and not just print a map, but they can download it, use it in their GIS applications. I'm guessing most of you are familiar with mapping and cartography, so it really allows you to own the data, to download it, and do analysis or maps and really anything you want. HOT, Humanitarian OpenStreetMap Team, leverages crowdsourcing and the community of mappers that come together to support activations. Activations are basically activities that we coordinate when something happens, when a big disaster happens. And over the years, we had over 200,000 volunteers that come to HOT and help us map specific parts of the world that get affected by disaster, by natural disasters. And what we do is we coordinate those activities, and we provide the information, either printed maps, like in the case of Nepal here in the lower right picture, or data that can be downloaded on navigation devices and used for response. We work with the large responding organizations, humanitarian organizations like MSF, Doctors Without Borders, and many different Red Cross societies in different countries. This is to give you an overview of all the field programs, basically where we work locally with the local community, with the local OpenStreetMap community, with other partners. This is basically the footprint of all the field operations where, the field programs that we do across the different continents. So going back to the three areas, disaster response, this is an example for Hurricane Maria in 2017. You can see like how over 2 months, 2 months and a half, the map has been, the more features like roads in this case have been added to the map. Over those 2 months, we had over 5,000 volunteers just for that activation, an average of 300 people mapping per day, 45,000 kilometers of roads created, 1.5 million buildings just for that activation, just to give you an idea of these projects that we do. As I mentioned, we work with organizations on the ground, but also those sitting in the decision rooms or doing damage assessment, where they need the information, the map information for that specific area to understand what was there before and to understand what has been damaged, and decide how to prioritize response. On sustainable development, something that we've been doing more and more recently is to leverage drone technology, UAVs or RPAS, to collect imagery locally. Satellites are very effective to cover large areas, but they're also expensive in some ways, and they're not always able to capture the area and the detail that we need for the maps that we create. And so what we have done is to help develop the capacity of local communities to image the areas themselves, collect the imagery, process it, put it together into a mosaic, and then trace it into OpenStreetMap. And then from that information, from those features, then the same teams will go on the ground and collect the information that I mentioned before, that local knowledge. We usually work with local partners like universities, students, student groups, and local tech companies or startups. We try to leverage those that have already some of the skills that are required to map. But to start, we don't really need cartographic or GIS knowledge to really start mapping in OpenStreetMap. One of the things that we have done in several countries are systematic surveys of specific features. So in this case, in Indonesia, we did a project mapping all the lifeline infrastructure, and we have tools that help us to go out, organize teams, and collect all that information in a systematic way, organizing the different survey areas and coordinating them through a set of tools. In this case, we're in Tanzania. We're looking at people that also look at the maps that the community created. They look at the risk, in this case flood risk, and they help us to understand not just the risk from the model, but also the perceived risk as it's from the local residents. So these are maps created by the community and then used by the community with the decision makers to really understand it, to really understand what are the areas most at risk, and provide that input, that feedback to all the planning activities. Here we're looking at a software called InnoSafe, which takes in hazard layers and exposure information, and it shows how you can take the data from OpenStreetMap, the buildings, and overlay it with the hazard layer, let's say the flood risk or the flood extent, and make an estimate of the impacted building. The number of buildings, residential, commercial, and so on. All that estimation is very useful to understand areas of risk, and it wouldn't be possible without a data set. They wouldn't have this granularity and the detail that you can find in OpenStreetMap. This is another example of how we use OSM data for malaria elimination. Here we are in Guatemala. Basically, the teams that go in the field, they need to know all the areas that they need to spray, and then they need to know where they sprayed, and then they have to come back after some time. And before using OpenStreetMap or the maps created with OpenStreetMap, they would rely on just whatever was available, usually old paper maps, and it wasn't up-to-date information like you can get from OpenStreetMap. So we've supported many of these projects in different countries in Central and South America and in Africa. And then finally, coming to the team that I'm working for within the tech team. We develop the tools that then we use for mapping, both remote mapping, but also the work that we do in the field. In this case, the main tool, probably the most famous, and if you go to HOT, you probably came in from the task manager. The task manager is, and you can find it at tasks.hotosm.org. It's a web application where we can create a project for a specific area, and then we can split that project into small tasks. So it's a microtasking software, basically, that allows multiple people, the thousands of volunteers that I mentioned before, to come together and map out specific areas. So it's really efficient because it basically allows you to lock a task, so there's no risk that two people will map the same area. There would be duplicated information. And it also allows project managers to understand how the mapping is developing and what's the status of completion. So I'll probably show you this after the presentation. And then specifically for aerial imagery, satellite imagery, we built the Open Aerial Map. OpenAerialMap.org is a place is a platform where you can find all kind of openly licensed imagery. It's imagery coming from big commercial satellite providers, and as well drone mappers, drone pilots that just want to share and make their imagery available. So it's an interface like this with a grid, each grid, and then if you zoom in, you get more detail, but it gives you a visual representation of the amount of images available in the different parts of the world. And then also related to imagery and OSM data, we built OpenStreetMap Analytics, osm-analytics.org, where you can go and select any area in the world or just an arbitrary, in this case, a square box around the island of Tonga Tapu in Tonga, and look at the amount of features that have been mapped in that area. And then you can also visualize, like in this case, I selected the features, the buildings in this case that have been mapped in 2018, and it shows you the areas. In this case, it's simplified as a grid, but you can zoom in and look at the buildings that have been mapped in the specific area. This is useful because it tells you some information about how old is the data, and also when and how it was created, like from satellite imagery, from drone imagery, and so on. Also in OSM Analytics, you will find another app on the top. There's 3 tabs on the top, which is called just simply gap detection. It takes the OSM data available for any part of the world, and it compares it to estimate built-up area from derived from satellite imagery. Some data set called, like you might know, called GHSL, or the World Southern Footprint Layer from DLR, from the German Space Agency, or there's a new data set that was created by Facebook called HRSL, High Resolution Southern Layer. These are all imagery-derived layers using machine learning applications that we compare with what's in OpenStreetMap, and we try to estimate gaps or where OSM is missing data, and then we can create specific projects to cover those areas if needed. And then just to mention, we also have the some tools that we use for the field data collection. All of our tools are available in GitHub. So if you're a developer or you work with if you work with software, open source software, you can go to github.org/hotosm, and you will find all the tools that that we have developed. One thing that we've done recently in the last 2 years, we tried to integrate machine learning applications, algorithms directly into the mapping. So here's an example that shows a project from the task manager, and the different colors shows you the amount of features that have to be mapped. So it's a visual representation that helps mappers to understand how difficult in some way each task is. Another thing that we have developed together with Facebook is a map editor called Rapid. If you go to mapwith.ai, you will find this editor that allows you to basically take information, take layers, features that have been extracted with machine learning and validate them into OpenStreetMap. So you're presented with a building, for example, that have been automatically extracted from imagery, and then instead of digitizing that building, you can just validate and say, yes, that's correct. So this is a very nice application and practical use of machine learning that we developed recently. As I mentioned at the beginning, we recently received support from the TED network to do a project over 5 years where we have this Audacious, and Audacious is the name of the project, goal of mapping the area up to 1 billion people, where 1 billion people live. So this is something that we're planning now over the next 5 years. We will be opening regional hubs in South America, East Africa, and Southeast Asia. And we're just starting this, so we really look forward to what this Audacious project will bring us to. Now, just quickly to recap and go into the main topic of the seminar series, imagery. This is the type of imagery that we use in mapping in OSM. Satellite imagery. I don't know how familiar you are with the different satellite imagery providers, but these are some of the type of images and sensors and satellites that we work with. We work mostly with Maxar, ex-Digital Globe from the US, and then in Europe, mostly for disaster response with Airbus with their Pleiades imagery. And then we've had some collaboration with Planet, and before that with Google with their SkySat high resolution imagery. As I mentioned, we have been developing capacity for UAV and drone imagery with local community pilots. We also partner with, for example, the World Bank for the large-scale surveys. So we've done some where we use drones, but also with manned systems, with LiDAR and photogrammetric cameras. And so through the bank or other partners, we often hire local imaging firms to do these collections. And then one other type of imagery that we've been using You might be familiar with street level imagery, similar to what you can find in Google Maps, the Street View. There's a project called Mapillary. I don't know if you are familiar with Mapillary. It was recently acquired by Facebook, but it allows you to contribute photos to a similar system where you can see imaging on the street side. It's all open, so anyone can contribute, and then you can use that imagery to add information into OpenStreetMap. So, for example, street signs or other building features. If you go to osn.org and basically just start editing, you will be presented with these type of what are called here background layers, but this is basically imagery layers, composite imagery layers that are made available by Bing, Microsoft. They were the first to make their imagery available for the OSM community. And then Esri, Esri has 2 layers, and then Mapbox also has a nice composite mosaic available for tracing in OSM. And then the Maxer premium and standard layers, which are composite mosaics of their most recent imagery available for anywhere in the world. So you have some choices that you can go through, look at which one offers the more recent imagery, look at which one aligns better with the existing data or GPS tracks, and then you can use it for tracing. As I mentioned, we work a lot with Maxer, and we help them to spearhead their open data program back in 2016, 2017. And so after, or even before disaster happened, they publish imagery with an open license on their open data portal. And that imagery then gets processed and put into OpenAerialMap, and then we use OpenAerialMap as a way to serve the imagery, to publish the imagery so that it can be used in GIS software or in the mapping in OpenStreetMap. Yeah, this is exactly the way that you do it. You go to openaerialmap.org, you log in, and then you can fill out some basic metadata, and then link to the source imagery. If you're familiar with the geotiff, the file that it's basically the imagery file, and it gets uploaded into OpenAerialMap and made available to anyone to use. This is just an example of a project in Kampala that we did a couple of years ago. This is a drone flight, and yeah, these are a few other areas, projects where we use imagery. We've done some damage assessment, but mostly has been done through research projects, trying to understand how we can leverage the crowdsourcing for damage assessment, basically understanding and tagging buildings based on their damage level, destroyed, damaged, or not damaged. We're just now discussing with Microsoft about operationalizing this, but at the moment it's been mostly done through research projects. If you go to the URL that I listed here, we also developed some UAV or drone mapping guidelines. It's an open source effort to make simple guidelines for those who just want to get started with collecting imagery with drones on how to do it. So it's open to anyone to contribute and open to anyone to use and yeah, to get started with drone mapping. One other project that I want to mention, it's called MapSwipe, which is a phone app. You can download it from the Play Store or the App Store. It's a microtasking app, again, similar to Task Manager, but in this case, you are presented with a question, looking at imagery, satellite imagery, or drone imagery, and you have to answer, for example, whether you see a specific feature in the imagery. As we engage thousands of volunteers using this app, and they all start swiping, then we automatically get large areas of imagery classified based on the question that we ask in the app. I'll show you an example. And what I mentioned before, the data gaps, we also work with a group called Disaster Ninja to try to better understand any gaps in your SEM layer, and how we can create new projects for mapping to fill those gaps. I'm gonna put this slide up as the last slide, and I'll take some questions, and then I'll show you a couple of other things live from the browser. But I thought this could be some opportunities, and if anyone in the audience in the meeting today wants to follow up with me, these are areas that we are looking to explore using imagery, using the machine learning algorithms. These are all things that we are looking to do basically related to imagery. So if anyone is interested, please contact me or through Chris, and I'll be happy to hear about the working together on these areas. But yeah, I'll stop here for a minute for any questions, and then I'll show a couple of things in the browser if we're good on time.
Yeah, thanks, Cristiano. We're definitely good on time. That's an excellent overview. And you've presented a list of opportunities for people to get involved. What would be the easiest way, in your opinion, do you think, for the audience members to get involved? Would it be downloading the Swipe app? Would it be just going online and mapping some villages? What do you think is the path of least resistance for getting involved?
Yep, that's a good question. Let me bring up the from the other screen. But I would say a good starting point is our website. How do I send that over? Try to recite it. Okay. All right. Exploring the website definitely gives you a good idea of the different projects that we work on, but probably the most immediate way to get involved is really to start mapping. So if you click on start mapping, you're taken to what I mentioned before, the tasking manager. And really, it's 3 steps really that you can follow, and basically you can start contributing to one of the projects. And from there, to do that, you will have to create an OpenStreetMap account. So if you already have that, then you just log in. Otherwise, you create it. But basically, if you go to Explore Projects on the Task Manager, you will see projects that are, in this case, tagged as urgent. The first, the default sorting is by priority. We have several COVID response campaigns that we've done, where I think 25 countries now. And these, for example, Rolly PH is for a recent typhoon in the Philippines. So these are all opportunities to start contributing right away. You can see how many people already have contributed to each of these projects. So let's say you open this one. This one, you have to map land use, which is a little bit more complicated, even though it's tagged for a beginner mapper. But let's see, let's look at this one. You have to map buildings, right? So you open this project. Here on the right, it shows you the area that we're looking to map. You see the different tasks as you zoom in. You will see some task of a block. That means that someone else has been mapping. You see that some tasks are green. It means that someone already mapped and someone else already validated that same task. But and there's also an example, a graph here showing the progression of the work. But anyway, once you get to this point, to a project that you choose, you do contribute. You can read, you should read the instructions of the project. You have to map within the area, the task that you're assigned to, and choose map the task. In this case, I believe all of the tasks have been mapped once, so I will be asked to validate. It automatically opens the editor. You just say edit now, and here you are in the in the standard OSM editor. You see you have this boundary. You have to stay within this boundary and map the features within this boundary. Right now, I'm only validating, but basically what I have to do is to look at the buildings that need to be mapped in this area, maybe change the background to get a better visual on the features on the ground. Let's try a different one. Okay, they all seem to sort the same one, but most of the buildings have been mapped in this case. You can see there have been some buildings that are not exactly square, like we try to encourage mappers to square the buildings. So in this case, you might want to make it a little bit square, just follow the correct geometry. There's also a shortcut here for squaring Q, and it will automatically orthogonalize the feature. If you see something incorrect, you can change it. Now, in this case, I'm only validating, but if, let's say, the map was empty, let's say there was a building here that someone missed, you can basically just add it. Create a building, tag it as a building, square it, and save. I'm not going to save because there's obviously not a building there, but basically once you save that feature, this building I created gets saved into OpenStreetMap. So it's more data you're basically adding to OSM and completed the project. So yeah, I would say tasks.howtosm.org is a good entry point for getting involved with HOT. And then of course, if you are a drone pilot or you produce imagery, openaerialmap.org is the place to go to submit imagery or to download imagery. If you want to do some analysis, you can look at different parts of the world. I believe we're Uganda here. Like in this case, this is the image that I was showing you earlier. Here you have the mosaic. If you zoom in, you can appreciate the detail of that imagery. It's been mosaic, so it's not just individual images or rectified. And then you take you can use the links here on the right. And for example, this is what is called WMTS, or Web Map Tile Service, or TMS, Tile Map Service. You copy the link, and then you can open QGIS or your JS editor, and you can pull that layer directly into your JS editor. So yeah, but and that's to use the imaging. If you want to contribute, let's say you're a drone pilot, you log in using your Google account, and then you are offered this form that I showed you before, where you can upload imagery. So you would have to provide the title, whether it's UAV, balloon, kite. We had those as well at the beginning. And then you provide a link to Dropbox or a Google Drive or a local file where you have your geotiff, your imagery. And then you upload it and you agree to the open license, and yeah, you contribute to Open Air Map. So I would say these are the two entry points. There are different channels that you can also use for communication. We have a Slack channel. We have a mailing list. We have a community working group. So these are all things that probably will come as you get more familiar with the work that we do.
Thanks, Cristiano. That's great. Does anybody else have any questions before Cristiano's done?
I was wondering, to what extent do you use base maps that already exist in the countries, like perhaps developed by the federal or regional governments? Do you like to just start fresh and just draw your own maps completely from the imagery, or do you try to integrate these existing sources?
Yeah, that's a good question. And we do try to use existing data if it's available. And the most, let's say, limited condition is that the data needs to be open. They need to publish that data under an open license. Unfortunately, things like Google Maps, Google Earth, and many other open data sets, or the free data sets, they're not really open because they're not made available with an open license that you can just take it and use it for anything that you want, basically. So if we want to use existing data and let's say import it into OSM to not start from scratch, we need to make sure that that source data is licensed in an open way. And so we've had different experiences in different countries, but we've had some good success with several governments to release, we call it release, because they basically usually have it locked into their systems, or maybe just like a printed map, and they never, actually took the shape files, the source data, and put it somewhere online. So we help them to release that data with an open license that is compatible with OpenStreetMap, and so then we do an import. We import the data into the OSM database for that specific area. We check it against maybe existing data, because there might be someone else that had already mapped that area. And we do a process of conflation. You basically take two existing data with this new data set and merge it together before enriching it with more crowdsourced mapping after that. But yeah, that's a very good question.
Thank you. I was also wondering how you deal with data from different time periods, like you have these different imagery sources, but for example, the Bing Maps, the Google Earth, doesn't always have a date associated with it. So how do you know you're using the most recent imagery?
Yeah, that unfortunately is still a challenge in many cases. We do have metadata for most of the Bing imagery from Microsoft, but many other providers, unfortunately, they just publish a composite mosaic that doesn't tell you which. You might have like an image from 2015 and right next to it 2019. And unless you do some analysis, and that's what we usually try to do, like when we published the project in the tasking manager, the project manager that creates that project tries to review the imagery layers available, looks at specific features that maybe she's familiar with, and then decides the Bing map layer or the master layer is more recent in this area, and so please, it shows in the instructions to use that layer basically. But we've been working and we are working with those providers to standardize the way that they create and publish the metadata, so that then we can better, we know better what date and then vintage the data that we create is. So yeah.
Thank you.
Great. Any other questions? Okay, well, thanks, Cristiano. Really appreciate that. I'll put up some contact information so everybody can, reach out to your organization and get involved. And really do encourage everybody to check out the Humanitarian OpenStreetMap team and check out their tasks and see if you can contribute.